the graph of every quadratic function is a parabola. It gives us that U shape. It's either concave up or concave down. And we developed a formula to figure out the position of that minimum or that maximum, that point of symmetry. We called it a vertex. So let's find the vertex of this quadratic function, or rather the vertex of the parabola that is the graph of that quadratic function. So our equation for the vertex, or rather the x-coordinate of the vertex, is minus b over 2a, where your function is of the form ax squared plus bx plus c. So if we apply that to our function, the b, the linear term, is minus 4. So I replace this b value with minus 4. And we divide by 2a, and the a here is that 7. So we end up with a positive 4 over 14. We can simplify that just a little bit and divide everything by 2. We get 2/7. So that's the x-coordinate of the vertex. And if I look at the picture here, in fact, I don't want to call it x, I want to call it t, because that's the input of my variable over here. Right? This was a function dependent upon t. Okay, but either way, that's the location in the domain on the horizontal axis, 2/7. That's the location of that vertex. And then if you actually wanted to figure out what y value that is, you need to evaluate it inside your function and see what does your function give you at 2/7. So if we took our function h and evaluated it at 2/7, we would get, let's go through this. We'd get 7 times 2/7 squared minus 4 times 2/7 plus 11, which is going to give us what? That 7 can cancel with one of those 7s. We end up with a 4 over 7 minus an 8 over 7 plus a 77 over 7. So 77 minus 8 is 69. Oh, wait, no. 77 minus 8 is, oh, no, that's right. 69. And then if I add 4 to that, that brings me to 73/7, which if we find a decimal approximation to that, which is about 10.43. So we told ourselves from this formula that the position of the vertex occurs at that t value, 2/7, and that point right there, because we plugged it back into the function, that y value was about 10.43.